All right, so today we're going to look at section 5.7, which is on solving not equations with absolute value, but inequalities. All right, so basically just like warm-up problem B, except change that equal sign to a less than, a greater than, and so on. All right, so the first thing, I'm just going to show you guys an example of where you could use this. I don't think this is on your notes, so for this part, you just have to watch. Okay.
Yeah, Mr. Hager is just going to show you guys how this works, that's all. That's how you can apply it.
All right, so let's say we had an example with temperature, okay? And it said that on one night, the temperature remained within 5 degrees of zero, okay, all night long. Okay, the temperature remained within 5 degrees of zero. What does that mean the warmest it could have gotten is? If it always stayed within 5 degrees of zero. Yeah, it could have gotten as warm as 5 degrees, warm. Or how cold could it have gotten? -5. Okay, so all that this is saying right here is the temperature all night long was between -5 and 5. Right? That's an example where we could represent it just like this. Basically, as long as the absolute value of whatever temperature you're thinking of in your head, if it's less than 5, it satisfies what we're looking for here. Right, so that's an example where we could use something like what we're doing today.
That's like yesterday, Mr. Hager, the playoff game in Minnesota.
Yeah.
It warmed up to 0.
Warmed up to 0. Yeah.
It started at -5 and it warmed up to 0.
I know, that was cold. All right, so if we were going to graph that on a number line, basically, we could graph any temperature between what two numbers? What did we just say we had to stay between, Caitlin? Yeah, -5 and 5. Okay, so the temperature could be as cold as -5, could be as warm as +5, or anything in between. Okay, that's a picture that might be something like what we do today. Okay, would this be an or would this be an and, you think? When you end up shading between two dots.
Like you connect them dots.
Yeah, that's usually an and. Yeah, okay, that's usually an and. All right, so you're going to see the same kinds of graphs we've done before. It's just the process of solving it. It's going to be one step different than what we did in the last section. All right, so some of the steps for solving these are going to be what you did back in 5.6. Okay, so some of that you already have in your notes, and we're not going to write everything all over again.
Yep.
Okay.
So guys, like we did in the warm-up this morning, like we did last academic week, that first part, instead of getting absolute value bars by itself on one side of the equal sign, you have that. It's already written for you. You're going to write what comes after the comma. All right, you're going to get the absolute value bars by itself on one side of the inequality sign. All right, whatever inequality sign it is, it could be greater than, it could be less than, it could be greater than or equal to, it could be less than or equal to. And then once you do that, all right, you're going to use the opposite operation to move stuff. Maybe you got to add something. Maybe you got to subtract something on both sides. Maybe when it's right next to the absolute value bars, you're going to have to divide, like we did in the warm up. But it's the same exact thing. And in that first step, we can treat that absolutely inequality sign as if it was just like an equal sign. We're doing the same thing. So as far as getting the absolute value bars by themselves, that doesn't change. It's similar to what we did in past weeks.
And you might not always have to do that step. Okay, if they gave you a problem, say something like this. This problem's good to go. Okay, the absolute value is already by itself. Now, if they did something like this, now we got to do step 1. Okay, we'd have to get this on the other side.
Yeah, guys, in that first step, you're usually doing, if the absolute value bar is not by itself, there's something else outside, you're usually doing one of 3 things. Either you're subtracting, you're adding, or you're dividing. One of the 3. Sometimes there might be 2 steps you have to do to get it by itself.
All right, so step 2, just like when we're solving an equation, we're going to split it into 2 problems. Okay, so that's where we usually draw our two lines and
You guys have that on
split
your
it.
thing?
All right, so for the first problem, we're just going to write the original inequality with no absolute value bars. Okay? Just like when we did it for an equation. We wrote the original equation, we just took away the bars. All right, now the second one, there's an extra step. Okay, for that second inequality, what we did before is we wrote the original, we took away the bars, and we made the number negative. Well, we're still doing all of that. Okay, we're still going to write the original. We're going to take away the bars. We're going to make the number on the other side negative. But this is the extra step right there. You have to flip the sign, okay, when you write the second one. When you have an equal sign, you don't have to flip it. Think if you took an equal sign and flipped it, it would look the same way. Right? But when you have an inequality and you flip it, it points a different direction. All right? So original inequality without the bars. Original inequality without the bars. Flip the sign and make the number the opposite. Okay, so there's a lot of stuff happening there, but we'll practice.
Remember we did absolute value and we got the absolute value bars by itself? And okay, there's nothing else outside the absolute value bars, and it equaled a negative. What did that mean? Does everybody remember if the absolute value bars then by themselves equal a negative? Anybody remember? Can absolute value be measured in terms of negative?
So what Mr. Wright is saying, could you ever have a problem
like that?
where you take the absolute value of something and get a negative as an answer? Alex? No.
What's the answer? Is there an answer? 2 words.
You already said the first one.
No solution.
Exactly. Right? Remember, what's absolute value mean? Three things. Distance from 0, right? We're never going to measure distance in terms of negative. All right? But understand, we're doing the inequalities. If the number after the inequality sign is negative, that's okay. Mr. Hager is going to show you guys an example.
Yeah, we'll go through.
Yeah. That's what I'm saying. I know when we talked about absolute value last week and equal to negative, there was no solution. With this, that's why Hager and I put, make the number after opposite. Your original might be negative, and then when you flip it and have to rewrite it, you might have to make it positive. Okay, we'll show you that when we do a couple examples.
All right, and then the last step, once we split it, we always use the same word last week. Okay? Anytime we split it, we always use the word and. Well, when we're doing an inequality, we have to decide what word to use. Okay? Our choices are going to be and, what's my other choice? Or. Okay, so for step 3, I have to decide, am I connecting these two inequalities with the word and or the word or? Okay, and here's how you can figure out which way you do it. If it's a less than or equal to in the original problem, okay, you're going to use and. Okay, and Mr. Roy wrote a hint here, if you kind of think how you pronounce it, less than. Kind of think of it that way, a little play on words there, less than. Okay. If you have a greater or greater or equal, greater or greater, we're just saying it a little different so you can kind of get the hint here. Greater is an or. Okay, so anytime your original problems have greater than or equal to, we're going to use an or in step 3. Less than or equal to, we're using and. And I think Mr. Roy just mentioned this already. Anytime you multiply or divide by a negative, we always have to flip the sign. That rule still applies in any step of this whole process we're doing. Okay, we could end up dividing by a negative in step 1. We could end up doing it somewhere in step 2 as well. Okay, so anytime we do that, we have to flip the sign.
And like I was talking to you guys about when we did that last problem on the warm-up, remember ands and ors. When you're graphing ands, what do you want to graph? Logan, you told me earlier, when you're graphing ands, what do you want to graph?
You want to graph the two points that overlap.
Only graph the overlap, right? If we're doing ors, what do we want to graph, Colin? Everything, right? Ors, everything. Ands, overlap. That's all. Remember that. So we did a whole big chart last academic week on that stuff, but it's not on these notes. So you have to remember that stuff.
Right, so our first one asks us to do two things. Okay, they want us to solve it and graph it. Right, so it says absolute value of 5 minus 3x. What's the symbol? How do we pronounce that, Kevin? Greater than or equal. Greater than or equal to 9. All right, so let's take a look at our steps. Okay, step 1, get the absolute value bars by themselves on one side. Okay, is the absolute value by itself here? About Maria. What do you think? No? Okay, what's on the outside of that absolute value bars? Yes. Okay, it is. Okay, when we say by itself, we mean that you don't have something like this. There's nothing on the outside of those bars. Everything is inside. All right, so step 1 is already done for us. Okay? Step 2, okay, we're going to split it into two problems. Okay, the first problem, all I want to do is write down the original inequality, take away the bars. Okay? Anybody think they can tell me what my first inequality is going to be? Just taking away the bars, and that's pretty much it. Kevin?
5 equals 3x greater than or equal to 9.
Perfect. Okay, there's our first problem. We're going to go through and solve it, okay, in a little bit. Now I need my second one. Okay, so for the second one, we're going to write the same thing we just did. We take out the bars, but we got to flip the sign, and we got to make the number on the other side negative. Okay, so anyone think they can give me my other inequality I'm going to solve? Corey? You can do it. So it's the same as the one we just did, except flip the sign. So just flip that sign and make the number here negative. Yeah, that's it. Okay, these are the two problems we're going to solve. So first one, we just took out the bars. The second one, we did three things. We took out the bars, we flipped the sign, we made the number negative. Okay, now we have to decide what kind of problem it is. Okay, if we're going to put the word and or the word or. Alex, can you pronounce that inequality for me?
Greater than or equal to.
That's a greater than or equal. So what word do we use when it's greater than or equal?
Or.
Put the word or. I like to put it right away so I don't forget to do that. Okay? So this is an or. So when we graph it, we're going to think about graphing everything. All right. Now, we'll go through, solve it, and see what happens. Okay, Ben, what's my first step to solve this inequality?
Subtract 5 from both sides.
Good. Subtract 5. And Ben, what's 9 minus 5?
4.
4. Now you subtracted. Do you ever flip the inequality when you subtract?
No.
No. Okay, anytime you add or subtract, we don't have to flip it. All right, and my last step. Callan, how do I get that negative 3 on the other side? Yep, by negative 3. Okay, so that cancels out. I get x. All right, what do I have to be very careful of right now? I just divided both sides by negative 3. I have to flip the sign. Okay, if I forget to flip it, it's going to come out wrong. Okay, so flip that sign. And now I'm going to use my calculator to divide 4 by negative 3. Okay, only reason I want to do that is because this is going to be a decimal, and I have to graph it. So it's more helpful if I can just have a number to graph rather than a fraction. Yep. Yeah, negative 1.3. Okay, if you're not sure, just take 4 divided by negative 3, and it's negative 1.3. Okay? Okay. Or, okay, so that's half my graph. Or now I'm going to get my other one. Let's see. Okay, Justin, first step here to move the 5 on the other side, just like we did over here. How do we move that 5 on the other side?
Subtract that.
Yep, I'm going to subtract it. So we get negative 3x is less than or equal to negative 14. Bless you. Okay, be careful with that subtraction. Okay, negative 9 minus 5 is negative 14. Okay, Alexis, next step, we're going to get that negative 3 over. How do we do that? Yeah, by negative 3. It's the same steps we just did over here. Okay, that's what's kind of nice. If you solve the one on the left, you solve the one on the right the same way. Okay, something I need to be very careful of right now. Sam, what do I have to be careful of here? Yeah, I got to be careful with the sign. What do I got to do? Yeah, I just divided by a negative, so I need to flip it. Okay, and then negative 14 divided by negative 3. Let's just do that out. We get about 4.7. All right. So now we're going to graph it. Okay, first thing I'm going to do, let me just, do you guys have a number line on your paper already? Is it blank? All right, so let's fill in some numbers here. Let's put 0. Okay, I just put it on the fifth mark from the left. I'll go 1, 2, 3, 4, 5. And let's go negative 1, negative 2. Okay, there's other ways you could number it, but I think this is going to work for us. All right, let's see, Jalen, what kind of circle am I going to put on negative 1.3? Closed. Okay, negative 1.3 is just a little bit to the left of negative 1. Okay, so just put it like that. Davin, what kind of circle on 4.7? Closed. Okay, so I'm just going to put it about like that. Okay, and Ariana, for my arrow on negative 1, which way does it shade, left or right?
Left.
Yep, it's going to shade left. Good. Okay, so we got arrow going left from negative 1.3. And Ryan, what about from 4.7? Shade to the...
Right?
Yep, we're going to shade to the right. Good. Okay, and there's our graph. Now, with an or, is it okay that they're going in opposite directions?
Yes.
Yeah, that's fine.
Graph everything.
Yep, just graph everything. Questions on that? That's it. So we're just going to practice a few of those. And that's the only kind of problem we're doing today, graphing absolute value conjunctions and disjunctions. All right, let's try. You guys have a 1C? No, it's 1B. All right. Who can tell me what's a little different about this one? Something I got to do here that I didn't have to do last time. It's not hard, I just got to remember to do it. Yep.
Divide.
Yep, what are you going to divide each side by? 3. Perfect. Okay, so Kevin, by dividing each side by 3, he just got that absolute value by itself. Okay. Now, in this case, I divided by 3. Do I flip the sign?
No.
No. If we divided by a negative, we would be flipping the sign right now. Okay? So in this case, we don't flip it. 21 divided by 3. Michaela, can you tell me what 21 divided by 3 is? 7. Now we solve it just like we did the other problem. Okay, in fact, this one, though, I think is going to be even easier because what's the number in front of x here? 1. The number in front of x here was a negative 3. So we're not going to have to deal with a number in front of x this time. So I'll be a little faster. Right, Rose, now that I get the absolute value by itself, what's step 2?
Don't you have to deal with like the 7? No, not the 7. You have to.
Something visually we're going to draw now.
Okay, thanks.
Yeah, we're going to split it. All right? So now we're going to split it into 2 problems. Logan, can you give me one of the problems we're going to split it into?
One would be x minus 5 greater than 7.
Perfect. X minus 5 is greater than 7.
And then
Okay.
the other one would be x minus 5 less than negative 7.
Perfect. So for the first one, he just took away the bars. The second one, you got to do 3 things. Take away the bars, flip the sign, make the number negative. Okay, and last thing I have to decide before I start solving it is what word goes right here. Am I going to use and, or am I going to use or? Yeah, Caitlin? Okay, why do you say and? All right, because they're pointing, let's just go back and look at this, pointing towards each other. So in this case, when we're going to use and or, we don't have to look if they're pointing towards or away from each other. We just have to look at the original problem and look at the sign. Okay, so what's the sign in our original problem? Yeah, it's pointing to the right, so that's a greater than or less than? Yeah, it's a greater than. Okay, anytime we have a greater than, it says to use or. Okay, so this one is or again. We are going to do an and next. Okay, this one is an or. All right, now to get x by itself, it's just going to be one step. Same step on both sides. Gage, how am I going to move that number to the other side?
Divide it. Well, did you add it?
Add it. Yep. So plus 5, plus 5. So I get x is greater than. Chloe, you think you can do this one? 7 plus 5? 12, good. All right, so we got x is greater than 12. Okay, don't stop yet. That's just the first one. We got to get one more. Or, Ryan, how do I move that number to the other side again?
You add 5.
Yep, same step. Whatever you do the first time, just do it again the second time. So x is less than negative 2. All right, so I'm going to do out my number line. I think I'm going to go by 2s. Otherwise, I'm going to run out of space. So let's put 0. Let's put 0 right there. And let's just go 2, 4, 6, 8, 10, 12. Okay, that'll get me what I need on the right. And then on the left, negative 2. Now, before I graph it, I just like to think ahead. Am I graphing everything? Or am I going to try to look for overlap? This is an or. Yeah? What were you going to say, Caitlin? Yeah, we're just graphing everything. So this doesn't require too much thinking ahead. All right, we're just going to graph everything. Justin, what kind of circle on 12? Open. What kind of circle on -2?
Oh, these things, right?
Yep.
Closed.
Open. Generally, when you're solving these kinds of problems, I'm pretty sure you're going to use the same circle for each one. Either both open or they're both closed. I don't think you could ever have an example where you have one of each. Not with these. That's not possible. Okay? So they're either both open or both closed. Kevin, on 12, which way do I shade? Left or right? Yep. Good job. Shade right. Rose, on -2, which way do I shade? Shade left. And that's it. Okay, with an or, you don't have to worry. We just graph everything. Okay, any questions on that one? All right, so what do you guys have? We have what, 2A? Do you guys have a 2B? Yeah, we got a 2B. And that's it. Okay, so Mr. Roy, maybe I'll do 2A and then you want to take a look at 2B?
Sure.
All right. All right, what's nice about 2A? What's nice about this one? It's going to save us a little time. Yep. Yeah, there's not a number on the outside of the absolute values. Step 1 is done. Absolute value is by itself. Everything is inside the bars, nothing on the outside. All right, let's see. Rose, what's step 2?
Step 2, you have to split them.
Yeah, we're going to split it up. Good. Okay, we'll split it into 2. Zach, can you give me one of the 2 problems we're going to split it into? Good. I like it so far. Less than 11. Good. 2W minus 1 is less than 11. Okay. Anyone else think they can give me my second problem? Just remember, you got to do 3 things. One of them you already did in the first one. Take away the bars. Flip the sign. Make the number negative. Alex?
2W minus 1 is greater than negative.
Perfect. 2W minus 1 greater than negative 11. Okay, Michaela, going back to that original sign, it's a less than. Do you remember what word less than means? And, good. So she checked her notes out. Wasn't sure. Referenced it. Perfect. Less than is and. Okay, so I'm not there yet, but when I graph this one, in my head, I'm already thinking about overlap. Okay, I'm going to look for where these are going to overlap each other. Okay, so keep that in mind as we solve it. Okay, I'm Ryan. Can you tell me my first step to get W by itself?
Subtract 2.
So 2 is being multiplied by W. So we're gonna deal with that after. Okay, first thing we got to deal with is the minus 1. Think about what's the opposite of minus 1. What would you put right here to cancel it? Yeah. So your goal is to make that disappear. Right? So we got 2W less than 12. Now we want to make that 2 disappear. So what's the opposite of multiplying by 2? Good. Divide by 2, that's gone. Divide by 2. Now, anytime we divide, we gotta be careful if we should flip. To flip or not to flip?
That's the question.
That is the question. Not to flip. Good.
How come, Kev?
Because you multiplied it by 3.
Excellent.
And Kevin, you want to just go all the way with this? What do you get? 12 divided by 2? Yeah, he's on fire. 12 divided by 2, we get 6. And. Okay, now let's solve this and see what we get. How about Sabrina? First step here? Yep. As I've said before, it's the same steps you just did before. Okay. Plus 1. And Sabrina, what's negative 11 plus 1? Negative 10. Okay, and Ben, the last step to get rid of this 2?
Divide by 2.
Flip or no flip?
No flip.
No flip, right? Even though we have a negative on the other side, that's not what we're looking for. Did we divide by a negative? No. Divided by a positive 2. And Ben, what do you get here?
Negative 5.
Negative 5. All right, now this is an and. So when you graph, what one word comes to mind when you think and? Graph, overlap. Okay, so as I do this, that's what I'm going to be thinking in my head. Think where they overlap. All right, so we got 6 and negative 5. So let's go by 2s again, okay, on our number line. We might have enough space, but I think let's just go by 2s.
Mr. Hager, would it be okay if they just put negative 5 on one side and 6 on the other side? Would it be okay with that? Okay.
Yeah, we got to make sure we keep our scale consistent.
I'm saying, Mr. Hager, they put a 6 on the right and then a negative 5 on the left.
Like right here and here?
I'm not saying it's kind of spaced out, you know what I mean? Like if they put the 6 over here and the negative 5 over there.
If they're the same, if they're like the same number from 0, like
Okay.
2 and negative 2, then we could just do that. But if they're different, I just want to make sure you guys number it.
Okay.
Yeah. Yeah, Kevin?
Wouldn't this be a no solution?
Well, let's see what happens.
And guys, most of the time on a test or on the homework, whatever we do in class, we're going to give you a number line that's already set up for you. So we'll kind of take this step out of it for you.
All right. What kind of circle are we going to put on 6? Open or closed? Yep.
Open.
Open. What kind of circle on negative 5? Open. They're always the same. And now let's just think in our head before we draw this. Okay. From the number 6, which way am I shading? Zach? From 6? Left. Okay, so what I'm going to do here, I'm just going to put an arrow for now, just so I remember, okay, I'm shading that way. What about on negative 5? Which way am I shading? Left again. Think about numbers bigger than negative 5. Are bigger numbers to the left? Zach? No. So which way are we shading here? Yeah, we're shading to the right. So, are these two things going to overlap?
Yes.
Yeah, definitely. Okay. If I were to draw the whole arrow, this one goes this way, this one goes this way. There's an overlap in this section right in the middle. Okay. So what I'm going to do is just shade between them. Okay, just like connecting the two circles. Okay. Any question on that part? You just graph the overlap. All right, so last one, Mr. Roy is going to go through with you. Same type of problem, and so I think this is our last one.
All right, guys, this one. Anybody have any idea how many steps? Well, before we even get to that, what's the problem here? What's wrong with this one compared to the last one we just did? What do you think, Corey? What needs to happen before we can split it, Corey? Huh? Okay. So what you're trying to say? Are you trying to say that the absolute value is not by itself? There's stuff outside of it. Okay. So that's the problem. There's stuff outside the absolute value. Right? It's on the same side of the inequality sign, outside of the absolute value. So I'm going to tell you right now, to get that absolute value by itself, it's going to take 2 steps to be able to split it. Anybody want to take a guess or think about what that first step will be to get the absolute value by itself? Does anybody know? Not yet. You're on the right track, but not yet.
Yeah, the divide by 2 is good, but that's going to be the next step.
Add 13, right? Remember, when you're doing these guys, always, like Mr. Hager said last academic week, do the thing that's further away from the absolute value first.
I think if you had a problem like that, okay, and you're trying to get x by itself, the first thing you always do is addition and subtraction. Okay? And then, if you have to do some division, we'll deal with the division last. Okay?
And I think Mr. Hager made a good point. We did this a couple weeks ago. We said, always try to move the thing that's the furthest away from the absolute value first. That's the negative 13. Right? It's not right next to the absolute value like this 2 is. All right? It's got that negative sign, so it's a little bit further away. All right? So like Caitlin said, I'm going to add 13. So I'm going to add 13 here and cancel it out. What else am I going to add 13 to? The negative 5. Now, somebody besides Caitlin, when I do negative 13, negative 5, and positive 13, my answer going to be positive or negative? Anybody think they know? My answer going to be positive or negative? Answer going to be positive. How come, Sabrina?
Because you're at negative 5, so
All right, remember the rule we said. This, all right, my 13 is positive. It's bigger than a negative 5. I always take the sign of the larger number. So it's going to be a positive 8. Bring everything else down. Bring everything else down. Davin, any idea what we might do now to get that absolute value by itself?
Would you put the 2 under the 8 and under the 1?
So what math operation? You're right on, perfect. You want me to draw a line here, right?
Yeah.
Want me to draw a line here? You want me to put 1 under there, you said? 2. What math operation you doing? Do you know? Division, yeah, you're perfect. So when I'm going to bring my Mr. Hager says to flip or not to flip. Am I flipping the inequality sign? No. How come? How come? Yeah, I'm not dividing by a negative here. I'm dividing by a positive. Leave my sign. Davin, why did you I agree you divide by 2. I'm right with you. Why? How come? What's the whole goal here? To get what by itself? Hey. What do those bars mean?
I don't know.
What do those bars mean? Anybody? Absolute value, right? I divided by 2 because I always want to get the absolute value by itself before I can split it. All right? So this is going to cancel out. 3W plus 8. Davin, 8 divided by 2.
What?
8 divided by 2. 4. Thank you. Good. Now, what point am I at now? What point am I at now? What am I going to do now, Kev? Split it?
2 equations.
Not equations, but when I have this, what are they called? I agree with splitting it. I just want you to use the right vocab. Anybody know? When it has this, it starts with an I. Michaela? Not sure. She's like, I'm not not sure. Anybody? Caitlin? Huh? Inequality, right? So just be careful. Kev, I agree with you, man. We're gonna definitely split this, but just be careful. When it's an equal sign, it's an equation. When it has these guys, that means it's inequality. Okay? So watch out for that table, Mr. Rowe. Split it, right? Kev, what goes here? What goes here when I split it? So do you want me to write it with the bars or without the bars? Without the bars. Yeah, I'm just gonna write the same thing that's here, just without the bars, right? 4. Now, Ryan J. What kind of a problem is this going to be? We have when I split up the two inequalities, I have to put a word there, right, when I'm doing these? Do you agree with me? Okay. How do I figure out what that word is? Not sure.
Not sure.
Michaela? Huh? What's it going to be? It's going to be an and, right? How do you know that, Michaela? Yeah, Michaela went back to the original problem, and she said that's a less than sign. So it's less than. Great or less than. When it's a less than, it's an and. When it's a greater, it's an or. All right? So this is going to be a and. Now, I'm just going to do the first step to set up that next inequality. The easiest, I think it's the easiest part. I'm just going to rewrite it without the bars. 3w plus 8. Now, anybody know what I have to do now? Maria, what do I have to do now? Switch the sign. Agree. So I'm going to go this way. And then make it negative. Yeah. Again, the first part is going to be exactly the same as what you did over here. Rewrite it without the bars. All right? Remember, we're going to split it. We're going to split it and switch it over here. Split it and switch it. Now I'm all set. Now I'm all set to solve. All right? Over here, I'm going to subtract 8. I'm going to subtract 8. 3w. What's 4 in negative 8? Anybody know? 4 and negative 8. It's going to be positive or negative? Negative. Negative what? 4. All right. Last step for this one. What do I do, guys? Last step. Divide by 3. Divide by 3. Divide by 3. W. It's going to stay as negative 4 over 3. All right. Remember, I'm not the negative's already here. I'm not dividing by a negative. I don't need to flip my sign. When I actually write in divided by a negative number, that's when I flip it. There's a negative already over here, it doesn't matter. I don't have to flip it. All right, so that's one side. Bring my and down. This one, same exact as the other. I'm going to minus 8, minus 8. 3w. Now, two negatives. I'm combining them. I'm not multiplying and dividing them. I'm combining them. What do I get? Huh? Negative 12, right? I keep the sign. Both negative, keep the sign. Add the numbers together. Justin, last step.
You would add 12.
Nope. Look what I'm doing the same step that I did on this one. Same exact.
Subtract 3.
No, not subtract. You're on the right track with the 3. I didn't subtract though. What did I do? Divide. Good man. Divide by 3. Divide by 3. W. Negative 12 divided by 3, Justin. My answer is going to be positive or negative?
Would be positive.
Negative divided by a positive.
Negative.
Negative. And then 12 divided by 3?
4.
4. Negative 4. All right, so it's an and, right? But I'm graphing an and. What does that mean? What's that mean, Samantha? But I'm graphing an and. How do I want to graph it? What do I want to keep in mind when I'm graphing it? I want to graph the overlap. Perfect. Thank you very much. All right, I want to graph the overlap. I want to move my number line down a little bit. All right, so I'm going to graph the overlap. Now, this negative 4/3, that's going to be, for me, that's going to be difficult. For me, that's going to be difficult to graph. So I can do one of two things. I can make it a decimal, which Mr. Hager's already got me thinking about doing over there, or I can make it a mixed number. I think for you guys probably gonna have calculators, so it might be easier to make it a decimal. All right, Mr. Hager's gonna make it a decimal by just dividing negative 4 divided by 3. All right, and he gets negative 1.3. All right, well, here's my two things. Now, let's do 0, negative 1, negative 2, negative 3, negative 4, negative 5. All right? So, Rose, for that negative 1.3, what am I going to put?
You're gonna put a little place in. Oh, it's closed.
Closed. How come?
Because it's got a line underneath.
Line underneath. Perfect. So I'm going to kind of go not quite in the middle, because in the middle of negative 1 and negative 2 would be like negative 1.5. This is 1.3, so I'm a little bit less. I'm a little bit less than half. A little less than half. There's my closed off. Now, this is an and, right? So I want to graph the overlap. So should I just go ahead and draw my line? No. What should I do? Yeah, put it up the top. Which way is it gonna go, Lewis? This way. I'm gonna put a little, it's like Mr. Hager did in the last one. Let's put a little arrow up top to remind myself. Ariana D. What about the negative 4? Closed circle where? At negative 4. What about my arrow? Pointing to the right. Samantha, what am I graphing? Yeah, they're pointing towards each other, right? So I only want, when they're pointing towards each other, and it's an and, connect the dots. That's all it is. Just connect the dots. There it is. Done. All right, so guys, you've got to remember your rules for adding and subtracting, for graphing ands and ors. All right? There'll be, I think there's, on the homework, I think there's like six of these. Maybe it might be even less, I forget. It might even be 4. I think we did like one of each, like we did today. A couple where there's nothing on the outside, one where there's one thing on the outside. I think the other one has 2 things on the outside that you have to move. Okay? As far as, I know Mr. Hager talked about this at the beginning of the class, but just to remind you guys before you guys get out of here, it's your last it's a full academic week, no days off this week. It's going to be our last week of new stuff. All right, this stuff we do is new. A lot of the stuff we do this week, we didn't want to spend a ton of time reviewing for the midterm, but this stuff we do this week, there's going to be some stuff probably Wednesday that'll be on the midterm, but as far as this stuff we're doing today, the stuff we do tomorrow, that's not going to be on the midterm. But we didn't want to fall behind for stuff for the second half of the year. Remember Thursday, nothing new this week, like we've done in weeks past, right? It's going to be a review day, then our test on Friday. Again, you'll get your reference sheet on Thursday night for homework. You can use it on the test on Friday. Midterm is next week, guys. Your next academic week is the midterm. All right? Monday, Tuesday, Wednesday, all going to be review days. You will have homework over shop week this week for like the first time ever all year. Maybe like the second. Maybe not. We gave it to a couple times, but we haven't done it in a while. There will be homework over shop week this week. Logan, there'll be homework over shop week this week. Stuff on the midterms. We can get you guys to start thinking about reviewing again. Homework, 5.7, and there's gonna be a few questions on there with midterm stuff.